For more information, please visit our website at DarkCybernetics.com. This is DarkCybernetics 101 C++ programming. Follow along with our free course documentation. In this video, we will talk about the arithmetic operators in C++, as well as go over some other features of C++, such as the incremental operators, decremental operators, as well as the assignment operator. This plus, so you see the idea of C++, and the idea of C minus. We'll just add add to a variable, and decremental will subtract from the variable. Here in this example, we have a main function. We have a cout statement that displays a value, and it does the inline operation, which drops down to the next line. And we have some inputs here for a variable we call solution and input. And you notice there's some errors here we will see in the compiler by the way we assign the variable. And we can run it. We can still run it though. We have a value, and it gives us our answer. Okay, so we don't know the answer, don't know the value for the variables because we have not assigned the values and the variables an answer. We can go about now talking about how to use each one of these inside of what else? Arithmetic operations in C++. In C++, there are other ways to do in mathematics. There's also a math header in C++. In this case, we will use the cin statement in the stream 4, which is part of the IO library, to input a number for an operation. We can see in a number. We need to display on the prompt some kind of message to tell the user what to type in. And for this part, the input part, we need to output some type of solution. Depending on the particular compiler, knowing which, where, and what to use is very important for speed's sake. We notice that we put the cout statement below the part where the variables are. We need to output, we need to make sure there's something inside of the bucket before we dump the buckets out, right? If we can think about a variable as being some type of placeholder unit or variable, we can space is read as a character too, so when we press build this time, right, there's an error. We can go about fixing the errors. One problem may be that we need to move the variables up to the top part of the program to alleviate some of these errors we get in the compiler. It says that there's a warning for the number of decorations for the scope, so we need to move it up above the mathematic operations so that when we perform operations to it, you can also minimize by pressing this plus and minus sign here. Right, we just move this up, and there's no copy. And with the mouse feature, when we press the second button, we can go up to the top and cut, and of course paste it. It could be pasted outside of the main function if you wanted to, or we could use something like define, but in this case we just paste the variables, the values we need for the solution for our number 1 and our number 2, which is we just subsection A as B. We've assigned each new variable to 0. They are type integer. As you notice, when we type in int, there are other types of variables in C++ we can utilize when creating a program. So if we want to use a particular type of integer value, or a long integer, or some other variable of our value, we could then in turn manipulate that value to produce a higher or a required sum. Okay, since we've assigned each one of these to 0, and our cout statement, we'll press the build button, and if there's no errors, it should return automatically. And if we're not sure if the compiler, we can move the bottom space up to see and check the errors. It says there's a warning, but there's no errors, which is the errors at 0, so everything should be ready to go here. So we press the run button, and it says we say enter a value. Once we enter some type of value here, and our solution is of course 0, so we've done no mathematic operations on it, so that's correct. All right. So let's go about fixing this. Right. We have a place for inputting a variable, and we need to go about producing mathematic operations for each one of the things. To do this, we need to do operations on 2 variables. So we need to have a place for addition, right? So we use the assignment operator, which is the equal sign, right? And we store it in solutions. Since in C++ the mathematics is left assigned. So we have a number 1, we add it to using the plus operator, there's an arithmetic operator, to our number 2, and we use the terminating statement, the semicolon here, right? And once we can copy paste this, right? We have to go up to the top to the edit part. We can copy, right, and paste it one for each type. And so if we are doing, of course, subtraction, we need to paste one for subtraction. We need to have one for, no, we need to say inside the C out statement, we need to know that we are inputting a value for B, and we need to know that if we have an input, we need to input for B, right? So if we output a message for B, we need to output for B. So down here we have our solution will be displayed and stored in point A, right? So we have number A, and there's a number B, and we do some mathematic operations on it. We input two numbers. We input numbers 1 and 2. 1 plus 2 is equal to 3, so we know it's correct, and our program terminates. Okay. Alright, so what other operators can we go about demonstrating this property with? There's a difference between different types of data types. In this case, we are using the integer data type. When we talk about data types, we're referring to the size of the variable. That really determines, what distinguishes the types we are experimenting with. Since we have a solution, we need to go about, we can use the same function. Well, this is not a function, this is a statement. Each line is particular in a program is called a statement. We can go about changing the operators, the operands, to subtraction, to multiplication, to division, of course, and we need to go about looking up to see we have multiplication and division, and we can go about putting in, we can use different types of comments. We need to also paste in one for modulus. Modulus just returns the remainder, and I think it's the percent sign. We can fix that later. Anyway, let's just go ahead and type what we want. We have one for addition, and what we can do for each line of code, if it works or if it does not work, we can just comment the line off. If we comment the line, we put in these double bars or bar, the forward slash multiplication symbol, and then we can block off an entire section of code for debugging purposes. And in debugging, we can go about fixing errors. So we can have a line for multiplication, and this is the line for division, right? And this will be the line for modulus. We can fix that. All right. And for each operation, we need to recompile the program to make sure that it runs. See, each time you compile the program, it makes an executable. And another topic usually mentioned is version control. For each version of the program, people generally keep a save document for each addition or each edit to the program. In this case, for this program, we just need to compile off the lines we are not using for particular purposes. Since we are doing a different one, we can just comment these off. Once we compile it, after we comment the lines, they will not work. Since each line is commented and there's paused, there will be no, there's no reason for it to work, because the comments are generally designed just for readability's sake. So once we comment these other lines off, we can test each one of the particular versions after we build it. Then we can test out the version for subtraction. So this time we will just press the build button, then we press the run button, and so we input a value for 10 minus 1 is of course 9, which is correct. And let's test the next one. We comment the line off, and let's test out multiplication. Okay, multiplications. So, okay, so you press the build button for us. Since there's no errors before, we just change one operand, should compile pretty fast. We press the run button, and we input two numbers, and we should get a solution. 10 times 10 is of course 100, so that's correct. That's correct. Alright, let's go down to solutions for division. In the division problem, we can remember that dividing by 0 is illegal. Make sure you go about doing it the right way. So, okay, we press the run button this time, and we divide a number that we know is divisible by, say, suppose 9, and we divide 9 by 3. We should get 3, of course. and we get 3. Alright, that sounds fine. Alright, that seems to work okay. And let's test modulus out. Modulus just holds remainder, so we know that when we take the modulus of a number, we get the remainder, and we just need to know a number that reduces a solution. So we can use a number like 5, and a number that's partially divisible by 9 is of course 2. So we can test that out to make sure we get the value 1. So we have 5, we can put 5 here, we put in 2, we should get 1. Alright, that sounds okay. And for more information, please visit our website at DarkCybernetics.com.